All right, guys, for this first video that you're going to take the notes for today, let's just change this. I'll change this 2 to a 1. This is the first thing you're doing. Really, we're going to look at inverse functions. And these three key characteristics for inverse functions, you can just stop the video right now and just take those down. All right, just write those down. Okay, and then once you're done taking those down, the other thing you can add to it is that here's kind of the main thing. When we talk about inverse functions, you basically switch the x and the y variables in the equation, and that'll give you the inverse. So you can kind of see if you switch the x and the y, it makes sense that the domain of f of x switches with the range of its inverse. And this function to the negative 1 of x, that just means inverse. And then the range and domain switch, so the range of f of x then becomes the domain of the inverse. Okay, now how do we prove that two functions are inverses of each other? This is where we use this. Okay, this is where, I don't know if you remember, if you did FOG and GOF, compositions of functions. So if you do compositions of a function and its inverse, they always equal x. And there's a reason why it always equals x. And it's this third reason. If you graph a function and its inverse, they reflect over the line y equals x. So that's kind of why we get this x right here. All right, so these are kind of the three main features, but they all revolve around just switching the x and the y. Okay, let's take a look at the first example. Okay, I'm going to move this. All right, so for this, let's kind of zoom in here. All right, this, you can take this down. So we're going to be given a function and its inverse. So the function is just our normal parabola, x squared, and then its inverse is this plus or minus the square root of x. Those above three characteristics that you should have just taken down, we're going to prove that those all are true. All right, and what we'll do first is, let's first graph these. So we'll kind of first work with the third characteristic, and then we'll move our way up, going over the domain and the range for each f of x and its inverse function. So if I graphed, let's put this on a coordinate plane. I know if I graphed x squared, this is just my parabola. Right? It's at the origin, the vertex, and then it goes up. Now if we graph both of these, I'll put this in red. If we just graph the square root of x, this looks like this. And then if we also graph it, saying plus or minus the square root of x, if we graph the negative root x, the negative flips over the x-axis, so it's really just a sideways parabola. Okay, that's what the graph looks like. Now, in a different color, the line y equals x is this. Okay, this is the line y equals x. And you can kind of see that if you folded this blue parabola over this green line of y equals x, if you fold this part over, it lies on this part. If you fold this part over the green line, it's going to be this part of the red parabola. All right, so we proved the third characteristic. It's symmetric, I guess you could say, a reflection to that line y equals x. Now, if you looked at the domain and range, well, we could just look at an xy chart to kind of prove this. So let's go back to the blue. So blue, I'm just going to get an xy chart for this, for the y equals x squared. So numbers I can plug in, like if I plug in 0, well, this 0 squared is 0. If I plug in 1, well, 1 squared is 1. If I plug in negative 1 squared is still 1. See, if I plug in 2, 2 squared is 4. If I plug in negative 2 squared is still 4. Now the one in the red, I'm going to kind of come up with a couple xy charts for this. So I'll put, I'm going to put, let's see here, square root of x, and then I'm going to put negative square root of x. Now what's going to wind up happening for this is that the y and the x's are going to switch. So I'm going to put these values in for x for its inverse function. I'm going to put 0, 1, I'm going to put in 4. So let's put this in red. So let's put in 0. I know if I put in 0 to this, the square root of 0 is 0, and I still get the same thing there. So that matches up. If I put in 1, well, I get square root of 1 is 1. Here, I just get a negative on the outside. So these are the y values. You can see how it switches. If I put in, 4? If I put in 4, well, the square root of 4 is 2. And then for this, square root of 4 is 2, but then we put the negative 2. So you can kind of see how, these switch. We had negative 1, 1, but then this is 1, negative 1, right? 2, 4, but then becomes 4, 2. Negative 2, 4, then this becomes 4, negative 2. All right, so the x's and the y's switch. So that's the main thing. So that's kind of the second characteristic. All right, and then the last characteristic where it says the domain and the range switch, let's first look at it. So if I'm in blue, I'm looking at the parabola. Well, you can put in any value for x. So this is all real numbers, or we'll say negative infinity to positive infinity. Now the range, you have a restriction. This is the smallest value here, y equals 0, and then it goes up. So this is brackets 0 to infinity. And then if I look at the sideways parabola here, you're going to see the domain and range is going to switch. So if we look at the domain, see how everything is just to the right? So the x value, I can't plug in negatives because I can't take the square root of a negative. So this domain is just bracket 0 to infinity, which is the same as this. Okay, the range, if we look at the range, see how this goes up forever and this goes down forever. So this is negative infinity to positive infinity. Okay. All right, trying to squeeze it in there, I guess using a different color. All right, so the main thing is that the x and the y values switch for a function and its inverse. So therefore the domain and the range switch, and it's also symmetric to that line y equals x.